So hello, my name is Balint. I'm part of the Swarm team since December, and I will talk about how I implemented the encryption what Daniel had a presentation before lunch into the Swarm code base. And as Daniel mostly talked about how it works, it was not easy for me to decide what should be a useful topic for this talk, because I wanted something technical about implementing it, but I guess most of the audience doesn't have any personal hands-on experience on the Swarm code. I did not want to just, browse some code, although I did not want to talk about how it works, because that's already covered. I'm also not a cryptography expert, so why should I talk about that? So I wanted to make a little bit more general point about the experience of starting to contributing to a big complex project, and how can you add the new functionality to a code which is way too complex and big for you to refactor, although you have problems with it. And yeah, I'm pretty sure that all of you have been in this situation that you have to add the feature to a code, and then you realize that that code is convoluted. So you have two options. One is to add your feature to it and increase the complexity and make it even worse, or refactor the thing, but probably you don't have. Oh, sorry. Actually, I think I have an app for that. Or it's not installed. Okay, then I will just try to be more active with my computer. So you have the option to either to refactor it, and then you don't have time for that, so you cannot do that. Then maybe I should just add, but then that's the complexity. So what should I do? And I think there is a general pattern here what you can do in these cases, and that is to get this is the code but is way too complex and you cannot really understand, and you know that you have to write things into it. And one of the options, if you cannot refactor the whole thing, is just to separate small parts which are responsible for something and try to extract those. Okay, this is something what I understand, I could extract, and this is something which I also understand, it's just a very small part of the whole responsibility. This is another something, let's extract these, and then I have 3 components which I like, and then there is still something which is messy and complex and you don't understand, but at least it's smaller, and it's separated. And then you can add extra well-defined boxes for your stuff. So basically this was the strategy what I tried to follow when I added encryption to Swarm, and why it was hard. To explain this, I have to talk a little bit about the Swarm code. So how chunk retrieval works in Swarm? Well, there are all these outer layers which are actually not complex, and I don't really want to talk about them. There is an HTTP interface, and then we had to think about how to change the API so it accepts the extra information, whether you want to encrypt or not the thing what you want to upload, or on the retrieval part you had to accept these long references which include the decryption key. That was easy, but inside what I found that there is this thing called DPA, which has a retrieve and a store function. Basically, this is the basic Swarm functionality. You have a key, which is the hash, and then you get the content, or you have the content, you want to store it, and you want to get back the key. So it was kind of clear that what will have to happen here, that the store function will have to have an extra parameter, whether you want to encrypt or not. And the retrieve function is easy because you don't have to change the API there. If it's encrypted, you have to decrypt it for sure. But here you can see this thing called chunker, and that was something complex. And it was clear from this that probably I have to touch that. There is also this thing which will be important later. This is the retrieve channel and the store channel. These are Go channels, and the chunker itself puts information there onto these channels, and then this same DPA object is responsible to retrieve or store chunks when something arrives on those channels. Yeah?
What's DPA?
Yeah, it's a distributed pre-image archive. But yeah. Yeah, so that was like one of the barriers to understand this code. That actually, even last week I asked Victor, what is DPA? I forgot. Yeah, so the problem is the chunker. So what is the chunker? So the chunker is the component which is responsible to split and join your content into this 4K chunk and build the tree, but is already described by several people, including Daniel in the talk. So this is the content, and then you split it into chunks. It hashes all the chunks, and then these intermediate chunks, they contain the hash or the reference of the child chunks, and also all the chunks always on the first 8 bytes contain the span, which is the size of the whole subtree under this chunk. So basically everything what's happening here is done by the chunker. So what is in one chunk? As I said, there is a span, which is the size of the subtree, and there is data. If it's a leaf chunk, then it's actually the data of the content what you want to store or retrieve. In the intermediate chunks, those are the references of the children chunks. And when we encrypt, as you saw in the encryption presentation of Daniel, then we encrypt, first of all, we have to add extra random bytes to the chunk if the content is not 4K. This way we can hide even the length of the content, so that's the padding. And then we separately have to encrypt the span and the data. And we just concatenate those two byte arrays together, and then we have an encrypted chunk. Just a note that because the span is also encrypted, it's not valid anymore. So in the first 8 bytes of an encrypted chunk is not the size of the subtree. The original length is hidden. So in the encrypted case, this tree looks a little bit different because like the chunks are encrypted, and these intermediary chunks, they contain not just, as references, they contain not just hashes, but the hash is always concatenated with the encryption key for that chunk. And I want to emphasize this because maybe it's not clear that all the chunks are encrypted with a different encryption key. So from this, it's clear that the branching ratio of this tree is different in the encrypted case because the references are longer and the intermediate chunks are still just 4K. So they can contain only half as much references. That's why this tree here, it has the depth is bigger for this example. Yeah, so what is a chunk? And here happened the first problem because my original naive idea was that, oh, encryption will be easy because basically nobody has to care about whether the content is encrypted or not. When I save it into a chunk, which is an object somewhere, the chunk will encrypt its content by itself because all the chunks are separately encrypted. And here I bumped into this issue that this is the chunk in the code, and if you know the Go language, then you know that in Go, whether a field is public or not, it's defined by whether the first character is lower or uppercase. So because as data, which is the actual content of the chunk, including the span and the data, is capital, it's a public field, and I have to tell you that overall the swarm code, this as data is written manually. Like the first 8 bytes are indexed, the rest is indexed, right? Everybody is adding to this thing. So it's unfortunately the chunk itself does not encapsulate its structure well. It doesn't have a well-defined API, and because of this, it's not easy to add encryption on the chunk level because I would have to modify all the code which accesses chunks, and I can tell you that it's everywhere, like in the network layer, storage, everything. And I for example, I did not want to touch anything in the network layer because this should just affect storage. So I had to give that up, and then it was trivial that it has to be implemented on the chunker level. But what's the problem with the chunker? The problem with the chunker that it's very complex. So everything what I described in this one big chunker code, it splits chunks, it joins chunks, it builds this whole tree. That's a pretty complex code by itself. It also does all the hashing. It instantiates these chunk objects, fill well this S data, and also it puts them on the retrieve and store channels for the DPA. So if I would just to add something onto this code, and it implemented twice because we have two different chunkers. So just to add this functionality onto this already, like, I don't know, 1,000 lines of code, I did not want to do that. So what's the solution? So let me again show the overall architecture. So we had the DPA that called a join or a split on the chunker. And then the chunker splits or joins a chunk, hashes the data, instantiates the chunk objects, and pushes them on the channel for the DPA to retrieve or store it. And then in the DPA, there are workers who are instantiated and constantly listening on these channels and retrieve and store chunks. So the chunker in this case is the blob on my first slide, and I wanted to extract stuff from it. And it was clear that, for example, hashing is something which can be extracted. Maybe I could eliminate the whole chunk instantiation and this channel-based communication, which is also hard to debug and complex. So these were my goals. So I did not want to just put the encryption decryption into the chunker. I could not use the chunk object easily, as I said, because of the public as data. And it was also a goal for me that I wanted to write a separate encryption package which is 100% independent from the Swarm code. I did not want to rely on the chunk type or the chunker or any other type. So this is what I done. I created an encryption package, and as you see, it works not on chunks but on byte slices. It does not depend on any other Swarm packages. And it can just receive a byte slice and the key and encrypt it, or the other way around. And it can be initialized with all the parameters what we need, like how long is the default chunk size, because we had to add the random bytes to it, and the initial counter for the counter mode encryption, and the hash function. So this is the encryption package. This is the interface of the encryption package. And the other idea was to separate this whole storing and retrieving and hashing and chunk instantiation from the chunker. For this, I created two very simple interfaces, a putter and a getter. A putter, what a putter can do, it can put chunks into a store. A getter can get chunks. It seems like it has some complex types, but if you check, these are just byte slices. So this is also independent from other parts of this Swarm code. You can put a byte slice and then it is hashed and stored, or you can give a hash and then the appropriate chunk data is given you back without depending on chunk or anything. And I actually made an implementation of this putter and getter called hasher store. So this hasher store is a putter and a getter at the same time, and what's awesome in it, that you can give it an encryption object, which implements the encryption interface I showed you earlier, and then it does the encryption. So you can provide a chunker with a putter, which not just puts the chunk, but also encrypts it. This will make the DPA and the chunker way simpler, as I will show you. It hides and executes all the encryption decryption. So you just have all different kind of hasher stores, and there are hasher stores which encrypt and decrypt, and there are hasher stores which do not. And as I said, it doesn't depend on chunks. So the DPA will be much simpler from now. There are no workers to get and retrieve chunks. It just what it does. For example, in the store case, there's an extra parameter whether you want to encrypt or not. And then it just instantiates a hasher store. You can say to the hasher store whether you want to encrypt or not. You can give a hash function. You can give an actual chunkster to to put somewhere the data, and then you can call the chunker in a way that you give them this putter what you instantiated, and then the chunker itself doesn't have to care about hashing or anything, it just calls the put. So this will simplify the chunker. Why? This will simplify the chunker. So there is no more chunk dependencies. The chunk type is not in the chunker anymore. There is no hashing. Chunker doesn't even know that things are hashed. It doesn't know anything about encryption. But it happens that it just receives a putter and it calls a put. So a lot of things were actually removed from the chunker code. I can show you an example. This is how the process chunk function looked like. You can see that there is a hasher which does hashing, and then it instantiates a chunk object, and then somewhere here it puts it into a channel to store it and wait until it's stored. So this code now looks like this. It just calls a put on the putter and put the chunk data into it. I also added another simplification. So the chunker was a weird object because it was an object, but it really did not store anything. Basically, it was more just a module. It had a split and a join function, and you could call this split and join function parallelly multiple times on different chunk data, and it did not cause any problems. So you could use the chunker like this, that there is a chunker, and then you call split, 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 and you did not have to wait for the first split to be ready. Instead of that, I wanted to do something like this, that one chunker object is responsible for just one split. I had a good reason for that, because I wanted to eliminate a lot of very complex function calls inside the chunker, which had a lot of parameters because they could not save anything on the chunker object instance. But this looks really like Java code, so I wrapped it into a split function, and in the split function implementation, I actually instantiate a chunker and then just throw it away. Before that, the chunker had functions like this, prepare chunks. You have to pass down all the information because they are not on the object, and with the stateful chunker, but I created its code like this because all the other data is just on the object itself, so it's way simpler. So actually, it did not look like this, but finally it looked like this. So I just had to call a join or a split function without instantiating a chunker. So let me summarize. This is how it looked. There was a DPA. It called join or split on the chunker, which did a lot of things. Instead, this is the old architecture. Instead, now it looks like this. So there is a DPA. It instantiates a hasher store with or without encryption, depending on the actual request. The hasher store encrypts or decrypts the data if necessary. It hashes the data, creates the chunk objects, and actually stores them in the chunk store or retrieves them from the chunk store. So actually, the hasher store can have two encryption objects to help instantiate it from this new encryption package. One is responsible for the span encryption, the other is responsible for the data encryption. And then the DPA can call the chunker as before, but the chunker puts and gets the chunk data and does all the extra tasks around that through the hasher store. So the encryption is really not something which just chunker has to care about finally. This is the new architecture. This is how it can compare. It looks more complex, but the individual components are simpler, so I think it's a better code. So with this way, I managed to make the chunker code nicer, although I did not fully grasp how it works. I just got the parts which I could get and extracted it, and I really suggest this technique for you when you touch complex code. Thank you for your attention.